Scale functions vertically. Okay, so I'm going to go back to our equation sheet. I have a mistake I need to point out. So first off, here's the sheet. I made a mistake when I made it. I put skinnier on the bottom and fat up top. So make sure you float these around. Those are the descriptive words I use to describe the difference of them. So stretching and shrinking, we have c times our function of x. So our function in this situation would be x squared, which is our black graph, black line. C is a real number. When c is greater than 1, so that's our blue one down here. Greater than 1 is 3, or 4, or 5, or 2, or any infinite number above 1. Our graph will become skinnier than our original parent function. When c is between 0 and 1, it becomes fatter. So 1/3 is between 0 and 1. It's fatter. If we had negative 1/3, it would be the exact same shape, but just remember it flips upside down on the y-axis, or underneath the x-axis. And negative 3 would be the exact same thing as blue, but right here, and black, same thing. So negative just flips it exactly on the bottom. So these still do apply when you go negative, but you just follow this rule up here for the reflections. Okay, so let's use this. Remember, when it's greater than 1, it gets taller. And when it's between 0 and 1, it becomes fatter. So let's look at our first question. Okay, we have a really interesting graph here. We have some points that we're going to have to look at and see what values they go to. So function g is defined as g of x equals 1/2 of f of x. So we want our graph to be smaller than this graph by 1/2. So when we plug in -4, we need to go halfway. So not to 2, but instead to 1. So look right here. So when we plug in -4 into our function, right now it goes to 2. So when we plug in -4 now, it needs to go to 1. And then when we plug in 0, it's going to go to 1 as well. When we plug in +2, instead of going to 2, it's going to go to 1 right here. It's going to come down. We're still going to go through, when we plug in 4, we're still going to get 0. So it's still going to come through here. To go through like that. And then this is going to come down, something like that. So it's going to be the exact same graph, but just smaller. And it looks like it's going to be C. This is a bigger one. This, they just moved it up. C looks exactly like it's it. This one's close, but this goes down too far. See how this matches? This 2 goes to 2. Actually, 2 goes to 3. This goes way too far down. It's going to be C. Okay, next question. All right, function g is a vertically scaled version of function f. So here's g, here's the new one. F is the original. We have a point here, both at 4. When you plug in 4, the original went to 16. When you plug in 4, the new one goes to 4. So that's a factor of 4. 16 over 4, or it's 4 times smaller. So 1/4 times 16 would equal 4. The functions are graphed where f is solid and g is dashed. So yeah, so when we plug in the number 4, we're looking at where does it go. It went to 16, and now it goes to 4. It's supposed to be a 16 right here. Try that again. There you go. 4, which simplifies to 1/4. Okay, so we're going to look for a 1/4 fraction, and there we are, b. Okay, we're looking at the points. You can see the values and where they go. Okay, function, this is the graph of function f of x, which equals log 2x. Where's the graph g of x 1/2 log 2x? Okay, so one thing, we're just looking at the points they give us, and we're going to cut it in half and see what values come out, or what we need to come out. So 1 is 0, so we're going to go through 1 no matter what, okay? Because when you plug in 1, we get 0. Half of 0 is 0, okay? So A is an option. B is not, okay? We can cross off B. Oops, can't cross it off. C is an option, as well as D, okay? So it only knocked off B. When we plug in 2, currently 2 goes to 1, so we're going to have to go to 1/2, all right? And then when we plug in 4, we're going to go to value of 1. So I'm going to go to 4 and look for which one goes to value of 1 and see if that solves our problem. Okay, so A is an option. 4 goes to 1. B goes there, but we've already eliminated that one. C does, and C does not. C does not go. 4 goes to 4 up here. You see that? And 4D goes not to 1 either. So it's going to be option A. And last question. All right, so here's a graph. G is a vertically scaled version. We don't need to actually know what that is. The functions are graphed where F is solid and G is dashed. Okay, so this is the original, and this is our new one. So it was going to 6, now it's going to 2. So what do we have to multiply 6 by to get 2? Well, here's 6. 6 times 1/3 equals 2. So 1/3 is our ratio here. We're just looking at the points right here. Okay. We plug in a number. What number does it come out to? So it's a 1/3 ratio. And, oh, I guess we do need this up here, actually, because we need to multiply the entire problem by it. Okay, so we're going to do 1/3 times 2, which gives us 2/3. And 1/3 times 6, which gives us 2. So 2/3 and 2, which looks like it's option A. So yeah, I was mistaken about originally not needing that graph. And we are right.